Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you are having a fantastic week. And hey, we can make it a little bit better because, well, you know, and it's hard to make it better. Let's face it, it's a 3-day weekend for a lot of people. It's something to look forward to. But hey, we're going to do our best because we have Ralph Bond himself. Yes, he is our science and tech trends correspondent joining us here today to talk about a number of stories, usually in 4. So, we've kind of slimmed it down, but it's a more condensed and more complete version of what we have done with Ralph for years. And I've really been enjoying it. Hopefully you have too. So yeah, we have 4 stories coming at you, and just stay tuned for that. But before we get started, computeramerica.com. That's where you'll find everything, including past shows, future shows, show notes, podcasts, archives, contests, giveaways, social media links, all that and more. You can find that there. Also, a link to Ralph's site where Ralph, hey, if you just want to hear his segments, we have a playlist on our YouTube where you can hear nothing but Ralph. Don't worry, the past shows always stay relevant because a lot of these stories, they're kind of things that are going to happen or are happening research-wise. So, feel free to check those out. And, of course, go to his website. You can find all of his show notes and his videos there. Now, with that being said, everyone, I guess we just jump right into it. So everyone sit back, relax. Here we go. And once again, Ralph Bond, science and tech trends correspondent, and, of course, longtime contributor to the show. Ralph, welcome back on. How you doing?
Hey, it's great to be back, and we've got some really fun stories this week, starting off with this crazy story about a bubble barrier to get plastic out of rivers. But I'm jumping ahead of myself, but that's just an example of the wild and crazy stuff we have that flies under the radar of mainstream press.
Definitely. And obviously, I'm going to let you do your intro, but yeah, that's the goal here, is to find stuff that you probably haven't heard of. So Ralph, tell the nice folks what your mission is here on the show.
Sure. For first-time viewers and listeners, what I do, I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets. I look for important, and sometimes they're kind of out there, wacky, wild stuff stories, but usually they're things that kind of don't capture mainstream press attention. And it's understandable with all the news cycle going on in the world. It's hard for some of these stories to bubble up to the top end. But I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it, across the whole board. And what I do, and what Ben and I both do together as a team, is try to just present the essential points in a really digestible form. And I stress to our audience to check out the show notes that you mentioned for images and posts and links to the articles, because we're just going to give you the highlights. If you want to dig deeper into the science or technology that's really embodied in most of these stories, you can do so by coming out to computeramerica.com, finding the show notes for today, and then clicking on the links and looking at the videos and other things of that nature. So there you go.
Perfect. Yeah. And of course, if you're watching the video portion, you can see all of Ralph's segment there. These stories can definitely get out there. And, just even looking at the thumbnails, I'm like, oh, yeah, that's right. That's time we talked about growing human ears and mealworms eating styrofoam.
Yes.
Always these stories are great, uplifting stories for Friday. So with that being said, I think we just jump right into story number 1.
Yeah. Okay. So the headline here is, and before I even give the headline, A++ for simplicity. Now, genius is not always complex. Sometimes the most profound genius ideas turn out to be incredibly simple. And you think, doing, why didn't someone think of this before? So with all that buildup here, here's the headline. A river in Holland now has an experimental bubble barrier to capture plastic waste. And I got this story first in the United Kingdom's Guardian, and then I did some more research on CNN, and it's covered elsewhere also. But here's the setup. Up to 80% of ocean plastic is thought to come from rivers and our coastlines. So 80%. Wow. So this past July, the city of Katwijk, and I hope I'm pronouncing that correctly, in Holland, installed a remarkable bubble barrier to capture plastic waste in the Oude Rijn, which I believe is in English would be Old Rhine River, that runs through the city before it reaches the North Sea. So that's just happened just this past month. Created by a group called the Great Bubble Barrier, the system includes a perforated 390-foot long tube placed on the bottom of the river, on its riverbed, right, at a diagonal angle. Now, here's how to think of it. It's like a soaker hose, because it's a hose with perforations, but instead of water, compressed air is pumped through it. And the rising horizontal curtain or wall of air bubbles from the tube creates an upward current that lifts the plastic waste up to the surface. And then, to complete the process, when it reaches, the plastic waste reaches the surface of the river, together with the flow of the river. So the plastic comes up and the natural flow of the river, the plastic waste is pushed to one side where it can be collected using a collection system. And with the capture system's ability to snag plastic as small as 10 millimeters, the Great Bubble Barrier team says they expect to be able to remove from 86 to 90% of the plastic waste in the river. And Ben, I'm sure it's occurring to you as you're looking at the video and thinking about this. This could be so easily deployed everywhere. You're not talking about building Hoover Dam. You're not talking about any kind of exotic. It's a tube with air. And a collection system. How genius is that?
Yeah, doesn't mess with the fish. Doesn't really block the river. Very, very genius.
I know. I just love it. Here in Oregon, of course, we have so many rivers, and river pollution for us is an issue, of course. And I'm thinking, my gosh, on the Willamette River here that runs through Portland, and then the Columbia, of course, it could be entirely possible to do something like this, especially the tributary rivers like the Willamette. The Columbia is such a large river that might be a little difficult to do, but all these other rivers, you could do this and help arrest the deployment of horrible plastic waste out to our oceans ultimately. So I love this story for its simplicity.
Yeah, and of course, if you mix it with, I think a fan favorite is Mr. Trash Wheel, if everyone remembers that solution, where it's a trash wheel that, kind of gobbles up trash and floating in rivers and deposits it into a dumpster. I mean, it seems like they're very simple and almost passive. Like, I'm not saying that this wouldn't take electricity to run and that kind of thing, but it's almost passive and clean up our rivers. That's,
I love it.
Very simple idea. And, Ralph, and like, obviously I know that river pollution and plastic and waste and that kind of thing, all a big problem. I guess I never really considered plastic that, kind of is flowing under the surface. Obviously surface trash is very easy to see and collect and that kind of thing. But like you never consider stuff going underneath the surface. So this solves that problem as well.
Ben, that's a really good observation. In fact, I hadn't really thought about it until you just mentioned it. Yeah. I mean, we think all plastic's just going to float. Yeah. Right. Wrong. And that's one of the things that's so well in the little illustration in the show notes, the little chart there that shows the fish and the little debris and stuff. It makes that point that a lot of this material is not just at the surface. It's kind of mixed into the under areas of the water. So this incredible, super simple system goes after that unseen plastic waste. Pretty cool.
Would be really cool to, just kind of clean up communities like that. And, the fact that it's almost completely self-sustaining, there's really no, other than picking up the trash that flows into the collection, it's pretty much good to go. So great, simple solution. You love it.
Hey, Ben, I'm going to do a little segue here just for a second.
Sure.
Last week, we didn't do a show together because you were out of town. I was on Vancouver Island in British Columbia, just to the north of us here. And we ended our visit in Victoria, the capital of the province of British Columbia. Mm-hmm. And one of the things we saw around the city, and you'll see how this relates, is these tubular poles on lampposts and stop signs and all this sort of thing, these metal tubular poles with a hole at the top and a sign saying, please put your cigarette butts in this. And on the sign, it explained that cigarette butts can be recycled. I didn't know that. And that they present a terrible waste problem, not only on the land, but in the water. And so I thought, wow, Canada, thank you. What a genius idea. It's so simple. These tough metal tubes, you could put a lit cigarette in there. It's not going to hurt anything, and they can collect this material. And then my wife and I, once we saw this, we started looking around and we go, look at all these cigarette butts. Unbelievable. Everywhere. And that's a terrible waste problem. So salute to the Canadians for figuring out this idea of these simple tubes. Now, maybe this exists in other cities in the United States too. I haven't seen it, but I would encourage everybody to look forward to this and encourage cities to do this. It is a way to reduce this horrible waste problem of cigarette butts.
Right. And I'm guessing if you can see on the screen there, I'm guessing this is what it looks like. Kind of.
There it is. Yes, exactly.
Almost like a cigarette itself.
There you go. Isn't that great?
And it's a great way to kind of bring awareness to these things because, cigarette butts, I think, are like the most littered item out there.
Yes.
Compared to like soda cans that are pretty obvious and things like that. Like, no offense to smokers. Smokers can do what they want, whatever. But I will say that there's this kind of misconception that they're made out of paper, they're filters, they'll biodegrade. It's not really littering if you do it. Those things take years to actually biodegrade and actually get out of there. Like it's the most common form of littering for a reason. Man, it's so good on them. You're right. I have never seen that, and I've been to a few big cities lately. I've never seen those around, but great idea as well. So
I think so too.
Tons of ways to get rid of litter, and everyone just don't litter. Of all the people, Ralph, like honestly, of all the people, like people who litter, that's such like an easy way to not do. Like you can actively not litter by just not throwing crap out. So I don't know.
Yeah. It's hard for me to wrap my head around it. I can't go there.
Yeah, me either. So story number one. Story number two, let's go ahead and move things over to a bit of a different topic, because obviously pollution, litter, that's all its own problem, but also there are some more pressing problems. And you like to save the planet, you like to, and obviously we need to walk and chew gum at the same time, but some people unfortunately face the problem of not being able to have fresh water, clean water.
Exactly.
I mean, you can look at Jackson, Mississippi, for instance. Obviously this won't fix that, but you heard about that, Ralph? That was awful.
Oh gosh, yeah. Oh my gosh, yes. It is, and it is coincidentally very timely because of the Jackson, Mississippi tragedy and the water supply problems. But
access
here's the headline.
Water, a huge thing. Yeah.
Oh yeah. So here's the headline: ships. Ocean-going ships with nuclear-powered desalination plants could help fight water shortage crisis worldwide. And I got this from a very, very interesting website called aquatechtrade.com. So it's very focused,
very relevant
on all things marine related and so forth. And I just love this story too, because it's not necessarily an A+ for simplicity, but an A+ for flexibility. And I'll get into that in a moment. So recently, a UK-based maritime technology company called Core Power announced its proposal to create ships with nuclear-powered desalination plants to convert seawater, of course, into fresh water. Now, the ships, one of the things that's so great about this idea, the ships would be based on existing standard cargo ship hull designs and would have the power plant, of course, and huge water storage tanks, which are shown in the illustration that's in the show notes. Kind of looks like a traditional cargo ship with a bunch of those cargo boxes, right? But in this case, those structures would hold the water. So the key strategy behind this idea is the flexibility to deploy desalination ships globally. to target areas of greatest need. That's the thing I just so resonated for me with this idea. I love it. Now, however, truth in lending, this is not the world's first idea to create floating desalination plants. But current floating solutions, particularly in the Middle East, are barge-like structures fixed to a static location on a coastline. So they don't move. They're in place permanently. And most of the current floating desalination systems in existence today use either generators powered by fossil fuels or hybrid power schemes pairing fossil fuel generation of energy with systems that use wind or solar powered solutions, which of course the wind and solar are subject to weather variables. So that's why the core power team in the United Kingdom advocates nuclear-powered, carbon dioxide-free solutions to offer consistent, weatherproof power. And a little more about their system. Core Power's proposal also calls for the use of next generation of nuclear reactors, such as the molten salt reactors and heat pipe reactors that offer increased nuclear safety and security. Because I'm sure a lot of listeners were saying, wow, putting a nuclear power plant on a ship and having it kind of go around the world, could this be a safety problem? They're very keenly aware of this. That's why they're looking at these technologies, which are much safer. Right. And both of these reactor types are low pressure systems, vastly reducing the risks of contact with radioactive material. So again, safety, safety, safety. They are also small enough to use modular shipyard construction, decreasing build time and cost. So again, you take the design of a standard cargo ship hull and you combine it with this easy to use or easy to deploy and construct power system. That's why they think this is practical and has practical legs to the idea. And these reactors having both modularity and walk away safety by design, meaning it can step back, will be able to provide cheaper and safer nuclear power for this application. And here's another difference with Core Power's system.
Yeah.
Traditional desalination relies on heat-based methods with water being boiled. So you have to have a lot of energy to boil a bunch of water, right? With water being boiled to produce a steam that condenses into drinkable water. Of course, we're talking about seawater being boiled. Now, instead, Core Power's proposed mobile ship desalination system would be based on the widely used reverse osmosis technology. And a little refresh, reverse osmosis removes contaminants from unfiltered water when pressure forces the water through a semi-permeable membrane. And you know what, Ben? This is such a well-established, well-deployed technology. You can even buy, and you may already know this, you can buy a reverse osmosis mini system you can put under your kitchen sink.
It's
not just that exotic.
Yeah.
There
We just
you go.
installed one of those a couple months ago. Very simple to do.
Oh, yeah, and it's not exotic. So you take cargo ship hulls, standard. You take a nuclear power system that's modular, very, very safe, and easy to be incorporated into a construction site. And then you combine it with this well-established, very well-known technology of reverse osmosis. And here you go with this idea of these ships that could be deployed to areas of greatest need. I just thought this was a winner on so many counts.
Yeah, and of course, to put some numbers to the story, I mean,
Right.
They say there that as countries increasingly find need for alternative sources of fresh water, blah, 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 growing, and they need a production of about 112 million meters, cubic meters of water a day.
Yeah.
Each one of these, I think, was expected to do, let's see, I think it was about 60,000 cubic meters or 450,000 cubic meters. The point is, each one of these that Core Power is supposed to produce should be able to provide a medium to large city enough water every day. Just for one of these. It's an incredible amount. And Ralph, much like your bubble story where you kind of said, way at the beginning, that, simple ideas are some of the best ideas, just finding ways to do it in new ways. I mean, a lot of this is just taking, almost like the nuclear power from subs that we already have, or in this case, maybe even changing to molten salt, taking these massive, truly engineering marvels that are cargo shipping containers, and desalination practices that are already used around the world, blending them all together. And hey, Ralph, you got a mobile, high capacity desalination plant, and that's incredible.
You gotta love it.
Of course, it's going to take a lot of money because none of those components are cheap, but still, it's possible, and that's the important part. So, very, very cool. I actually do like that story a lot. Story number 2, story number 3, we can go ahead and jump right into this. And, if anyone's ever been to Vegas, I think Vegas is one of the best examples of this. These giant buildings that just rise up out of nowhere, covered in glass. They're, they're very, very cool to see. But, they're, let's face it, all that surface area is actually, leaching air conditioning. It's reflecting light. It's all, really a lot of useless facade. So story number 3 could definitely help, places like Vegas a lot.
Yeah. This is great. And another thing, the last 10 years of my career before I retired, except for, of course, being your correspondent, I worked for Autodesk, and I worked for the division that was involved with what was called building information modeling, which was all the design software technology for the construction and building and architecture industry. Right. So this story really resonated with me. But here's the headline, folks. An innovative solar glass facade will generate all the electricity needed for a multi-story building and much more. This is a great story. I got this from interestingengineering.com. And friends, this is a really fun website, by the way, interestingengineering.com. And it certainly is interesting. So let's set things up here. Of course, you think about any city, any major city with high rises. Today, it's very, very common to see solar panels on the rooftops. And that's great. I applaud that. I think that's wonderful. But here's the deal. What if a huge portion of an entire side or multiple sides of a building could generate electricity? Well, to demonstrate this possibility, a building under construction in Melbourne, Australia right now will have an innovative outer facade comprised of glass panels with photovoltaic technology baked in. And most solar energy capturing technologies for building facades, because they do exist, it's not the first time on Earth someone thought, hey, let's put some solar panels on the side of a building. No, that's not what we're saying, but bear with me, you'll see the difference. Involve attaching traditional, let's be honest, not that very visually attractive solar panels to the wall surface. So that's out there, but it's not very, neat looking. But the team at Australia-based design studio Canon wanted to pursue a much more aesthetic approach. They realized that using photovoltaic cells embedded in panels that look like beautiful reflective glass window panes would be a great idea, and I certainly think it is. And after clearing a host of testing to gain safety approvals, the plan for their 8-story building is to have the north-facing facade, and I presume the north-facing in their situation is the one that's most optimally exposed to sunlight. So the plan for the 8-story building is to have the north-facing facade incorporate 1,182 thin film photovoltaic solar panels made by the German firm Avansis. And you should dig into these guys. I did as well, played around in their website. They're fascinating bunch. So the facade's design. Now you need to it would be great if you have the image of the building, because this will explain what I'm about to say. So the facade's design is comprised of alternating vertical columns. That's the best way I could describe it, of solar panels and regular glass windows. So it's not that the entire fenestration or window working of this north-facing facade, we're not saying the entire thing is made up of these photovoltaic solar panels, but it alternates. So one row, vertical row, or row may not be the right word, column, and then it alternates with glass that people can look out of. That's the story here.
and for anyone who's simply listening and not watching, instead of a flat, flat kind of surface that most skyscrapers would have, this is like almost like little bump outs, and each of the slopes, one half of the slope is the the photovoltaic cells, and the other
Yes.
half are windows. So it's
Yes.
also angular as well.
Yeah. So it's kind of angular, sort of like a corrugated washboard. That's young people may not know what a washboard is, but it's sort of like that. It's like like you say, the kind of protrusions in a pattern. Really, and it's a beautiful looking building. I think it looks great.
Yeah.
So here's the payoff. Here's the ding, ding, ding on this one. And this new facade will generate 50 times more electricity than if solar panels were only installed on the roof of the structure. And this will generate far more than the building's total electricity needs. And in fact, some of the articles I read about this project said, so because of this, the roof can be dedicated to a gathering space, or they could do one of those green roofs where they put plants and stuff on top, so they don't have to use the rooftop for the solar panels. And they can use it for a variety of different purposes if they want to. But going back to this project, and with so much green energy generated by this building, they estimate that the building will prevent 78.4 tons of carbon dioxide from being released into the atmosphere every year, because, of course, they're going to be using green, renewable electricity generated by the building's facade. So bravo to our friends in Australia for this project and this idea, which actually is kind of a collaboration with the Australian firm Canon and the German firm Avansis. So, wow, cool stuff. I hope to see a lot more of this as we go forward building new buildings.
Yeah, and and just looking at Avansis, who are supplying the the photocells, they're
Right.
I just found a press release from, when was this, March 2nd, 2021, so a little bit over a year ago, but they reached about almost 20% efficiency for their photocells. Even if you put in your solar panels, let's say 15, 20 years ago, those things were getting like 8, 10, 12, like 8 to 10% was a pretty good efficiency for 20 years ago.
Right.
I'm thinking more like the consumer one. So I mean, Ralph, efficiency for these solar cells are getting better and better year over year. So projects like this, they may seem and a lot of these are rendering. I believe you said that they got permission to build this thing, so it is going to be built eventually, but expect to see a lot more projects like this, especially as efficiency goes up. Because, Ralph, let's face it, if you are building one of these things and you can say, okay, we're building an 8-story building, that's going to happen either way, but we can also turn this into a money generating, energy producing, or at least subsidize itself with energy production. Why wouldn't you do that? And expect to see a lot more of these.
I think so. I think it's great. I just love it as a trend. I hope to see more of. And really, instead of building giant green projects, green energy projects, which should happen, why not build a little bit of green energy projects into everything that we build? That's Amen.
It seems to be a theme for a lot of the stories that we kind of bring here today. So. So there's story number 3. Story number 4. This is, once again, pigs get all the best medical care that we can find. No, joking. But story number 4 does have to do with people who, unfortunately, I think a lot of people don't know this, is, to repair someone's eye, and especially the cornea, that's one of the things that when you're an organ donor, of course, people think about, the heart, the kidneys, the lungs, so on and so forth. They'll kind of salvage from, from a person. And again, kudos to everyone who's an organ donor. But the cornea is actually one of the most important things that they get from an organ donor. And you do have to wait on a list just like you would for a kidney or anything else. Story number 4 might be some relief for a lot of people.
Yeah, story number 4 could be a big game changer. And again, salute and thanks to all of the poor little piggies that give up their lives to help us with medical research. It's as an animal lover, it's kind of painful, but on the other hand, my God, what an amazing! It seems like every other week we're talking about some fantastic medical breakthrough thanks to our little piggy friends.
Yeah.
But here's the headline: cornea implants made from pig skin restored eyesight in a small clinical trial. And I got this from the Smithsonian Magazine. Great article. So here's the setup. And Ben, you were kind of alluding to this as well. So corneas with mild damage can heal on their own. I've been there. But some people with severe conditions may need a human donor cornea graft to regain their vision, as you well established in your comments. Cornea grafts, and also you alluded to this, can be very expensive, invasive, and time-consuming surgeries, not considering the wait list and so forth and the need for a human donor that you mentioned. So again, they can be expensive, invasive, time-consuming surgeries that require patients to take medication for more than a year to ensure their bodies don't reject the donor tissue. So there's that part of it too. You wait a long time, the surgery is very intense, costly, and so forth. And then you've got to take medication.
You have to suppress your immune system just like you would for anything else. It's really tough.
Yeah, exactly. So here's the great happy news in the medical world that we can end our show today with. Now, researchers at the Thor Bulkhead, I'm not even going to try to pronounce this, Linköping. It's in the show notes, folks. God forgive me for our Swedish friends. So at this university in Sweden, they've developed a novel solution involving bioengineering cornea implants using medical grade collagen derived from pig skin to create a transparent hydrogel. Now, again, we mentioned at the beginning of the show that we super simplify. If you want to get into more of the details, biological details, scientific details, get to these articles, okay? But in a recent experiment involving 20 participants, surgeons made a tiny incision in each of the patient's corneas and inserted the hydrogel, which helped thicken and reshape the cornea to restore its functionality. And you want to end on a high upbeat note, get a load of this. Ben, the results so far, unbelievably encouraging. 14 of the 20 participants were blind before the procedure, but regained some or all of their sight after receiving the implants. They were also able to wear contact lenses again. And 3 of the blind patients achieved perfect 20/20 vision after the transplants. Hooray. Wow.
That is really incredible. And I'm sure that a lot of people who've watched the show for a long time, I got the laser eye surgery where they kind of reshape your cornea, to kind of fix nearsightedness and farsightedness. If I'm reading this right, Ralph, the hydrogel thickens it up and kind of reshapes the cornea.
Well, that's a good point. Yeah.
I'm wondering if that can then be followed up by corrective laser eye surgery, and then you could go from being blind to like those 3 lucky participants getting perfect 20/20 vision. That'd be a game changer for a lot of people.
Oh boy, yeah.
By the way, let's see if we can do this. Hopefully this works. Let's see if we can do this. And just for all of our Swedish friends, let's see.
Linköping.
Okay, so that's the name of the university. Linköping. Okay, there you go. So
because I felt bad, I had no clue.
Yeah. So hey, Google to the rescue again. So with that being said, Ralph, that was definitely a great story to kind of end on, and we're definitely going to do that right there. Everyone, if you want to find out more, computeramerica.com. We have the show notes right there, and of course, you can find more of Ralph's segments. Ralph, thank you for taking the time, and I hope you have a great 3-day weekend. And everyone else out there, I hope that you have a great weekend as well. So until next time, we'll see you here. Have a good one. Bye, everyone.